Okay, so the last bit of rules that we learned to do was the product rule. No, it was the chain rule, right? And that told to multiply derivatives together. So when they're in like a chain, so one going inside the other. So for example, e to the x squared is taking the derivative of that. Well, what's the way we do that is we think of x first going to x squared, and then going to whatever we get to here, we write e. And so the derivatives of this are 2x and e to u. And so to take the derivative of this, we multiply those two things together. And that's that. Okay. Okay. So the question that must be burning inside you is, well, how do we take the derivative of two things multiplied together? So how would we take the derivative of x squared times e to the x? So this is not a chain, right? Because what do? Well, we do x squared, but we do e to the x separately. And then we multiply them at the end. So it's not the same thing as this. Okay, so what is the rule? So it's actually not hard to figure out. So let's pretend we've got a rectangle and this side is x squared and this side is e to the x. So what's the area of the rectangle? It's the product, right? I mean, that's, so this is just the geometric way to think about products. You think of products as an area. That's kind of like a natural thing to do. Well, let's say, now, we're interested in how this thing changes. Okay, so let's change the rectangle. So let's terrible. I mean, that's if the sides are changing, we can see how the area is changing, right? So what is this? Well, this is the change in x squared. This is the change in e to the x. And this little bit here is a change in e to the x times the change in x squared. Okay. What is this area here? It's e to the x times the change in x squared. Right? So if this thing changes by a little bit, it gets multiplied by e to the x. If this thing changes by a little bit, we've got to multiply it by the x squared. Okay, so that means the change x squared e to the x, we just add up all the rectangles together, is change in x squared times e to the x plus x squared times change in e to the x plus change in e to the x times the change in x squared. Okay, it's all alphabet soup. But hopefully it makes sense, right? The change in the area is adding up those three things. So how do we turn this into a derivative? Well, how do you turn anything into a derivative? If you've got the rise, what do you divide it by? A run. Okay. And then we make our intervals smaller and smaller and smaller. All right? So over here, we get the derivative of x squared e to the x, which is what we want. Well, what do we get over here? We get delta x squared over delta x times e to the x plus x squared times delta ex over delta x plus delta e to the x times delta x squared over delta x. When this becomes really small, what does this become? It's the derivative of x squared, right? Times e to the x. What happens here as delta x becomes really small? What is it? It is the derivative of? The derivative of e to the x. Derivative of e to the x. And what happens to this as delta x gets really small? Well, one of them multiplied gets a derivative, but then we gain the derivative and then we're multiplying it by something really small. So we get nothing when we get it really, really tiny. Okay? So it's like two small things divided by one small thing is a small thing. Well, we know the answer to this now. The derivative of x squared is 2x. The derivative of e to the x is e to the x. Agora, it's a miracle. We've just figured out how to take the derivative of this. Okay? And hopefully, so I'm not going to test you on this. I'm not expecting you to do this, but at least it explains to you why it's of this form, right? Because basically we've got a rectangle. It's a product of two things, so both things are changing. So it's adding two things that give that change. So this is the change that comes about because x squared is changing, and this is the change that comes about because e to the x is changing. And so we add them together and we get the total change. So let's write this as a rule then. So this is known as the product rule. It says that if you multiply two functions together, when you take their derivative, you get f prime of x times g of x plus g prime of x times f of x. This is known as the Leibniz product. Just back in the 17th century, that was the first person who figured that out, wrote that down. Okay. Let's double check it on something that we know. Okay. What's the derivative of x to the fifth? The product? 5x to the fourth. 5x to the fourth. Okay. Let's do it a different way. Let's think of x to the fifth as x squared times x cubed. Let's use the product rule on that. So what is it? It's going to be the derivative of x squared, which is 2x times x cubed, plus the derivative of x cubed times x squared. Look at that. So that's another way to think about why it has to be like that, because it works. Not so. Okay, so now we can do lots and lots of, so just like before, now whenever we introduce a new rule, we can now just differentiate all kinds of stuff. Okay, so let's x times e to the x. Okay, so again, but you notice that part of the skill in differentiating that is parsing it. It's like seeing how the thing is put together. So we look at this and we see that the way that it's put together is that we're taking a product of two functions, therefore we use the product rule. Okay. So we've got to recognize when things are a product, when things are a chain, or when things, you know, whatever. However the function is put together, we've got to unpack it into its little pieces, differentiate each little piece, and then sort of put it together. So the thing is, we know how to take the derivative of x, we know how to take the derivative of e to the x, and they're put together by a product. So therefore we know how to do this. Okay, so the derivative of x times e to the x plus x times the derivative of e to the x, e to the x. And then the last thing is just the tidying up stage. Let's do x times ln of x now. Same thing. So after a while, you just see that, you know, that functions are different, but they're put together the same way. So you just use the same process to handle it. Again, the derivative of x is 1 times ln of x plus x. And what's the derivative of ln of x? 1 over x. Oh, this time we get a bit more tidying up, right? So it's ln of x plus 1. That's a bit funny, but anyway. What about e to the x times ln of x? So you have a go at that now. Just try that by yourself on paper now. Okay, let's try again. So, derivative of e to the x times ln of x plus derivative of ln of x. Not much there to tidy up, is there? Okay. Next, we're going to do the quotient rule, but quotient rule is a little bit obsolete because you can always think of a quotient as a product, right? So let's do e to the x over x by thinking of as e to the x times x to the minus 1. Okay. So, derivative of e to the x is e to the x plus the x. What's the derivative of x to the minus 1?
Negative x to the negative 2.
Right, negative x to the negative 2. Okay, so let's tidy this up. E to the x on x minus e to the x on x squared. That's a good enough answer, but if we wanted to do more work, what would we do? If we wanted to do more algebra, what could be the next step? Yeah, what do we call that when we've got fractions and we put fractions together? What's the magic phrase? We find the, what's the thing on the bottom? Common denominator, right? So that would be x squared. So that would be x e to the x minus e to the x. You don't have to do that homework or tests, but the reason why we might want to do that is because later on we're going to be doing things with derivatives, and this is a form where you can figure out things more easily than this. We'll get to that in another case. Okay, so I'm going to leave that there because we're going to do that problem in a different way in a little bit. But let's just pause and think, well, what kind of questions can I ask you? Well, I can ask you typical kind of questions like, what is the tangent line of y equals x ln of x at x equals e? That's a really typical problem I ask, isn't it? Okay, and you know, okay, I just need a point and a slope. The point is x is going to equal e. What does y equal? What does ln of e equal? 1, right? Because ln of something is what is the exponent of e to it. So that'd be 1. X is e, so it's the point EE. Okay, what is the slope? Well, luckily we've just figured out what it is over here. The slope is ln of e plus 1. ln of e is 1, so the slope is 2. Now that we know the point and the slope, we can put in the point slope formula, so we've got y minus e equals 2 times x minus e. Okay, so notice that when it's in this form, it's in the form delta y equals 2 delta x. Right. So how much more is y when x equals e plus 0.1? Well, it's just going to be 2 times 0.1, so it's going to be 0.2 more. We've done those kind of questions a lot. Anyway, you can also write this as y equals 2x minus 2e plus e is minus e. And that's it in the slope intercept form. Okay, so all we're doing is we're learning more functions to differentiate. So eventually we're going to, anything that you can kind of do on your calculator, any kind of formula that you're given, we're going to learn how to differentiate that. Of course, it might be so complicated that it might take you, like if it's lots and lots of things put together, you'll see that it can get quite complicated. But in theory, you'll know how to do it. You'll just say, oh, these are the rules, these are the components, and then you just turn the crank. It really is a machine for taking derivatives. As long as you know the rules, you can take any derivative. Let me give you a question where you actually have to think. You need to know your derivatives, but let's say I give you a demand curve. And let's say the demand is P equals 80 glasses. I'll read my questions. Times E to the minus 0.003 Q. Okay, does that make sense as a demand curve? It does, right? Because if we graph it, when Q is 0, we're at 80. And then it's going to decay away. So a typical demand curve, right? So Q, this is P. For there to be a lot of demand, there has to be a low price. Okay, so that makes sense. Here's a question. Give the revenue curve and marginal revenue. Now we have to think. How do we get revenue from demand? Can someone give me a formula for revenue? You're selling a good, so how much money you get depends on two things. What two things are those? Sorry? Profit plus cost? Well, yeah, that's true, but that's not going to help us in this situation. We haven't got anything to do with profit.
Is it price times quantity?
Price times quantity, yes. Exactly. Price times. Now we have been given information, right? Because we've told what price is as a function of quantity, so we can turn that into 80Q times E to the minus 0.003Q. And so now we've got a revenue curve, right? So how much goods you put out there, that's telling you how much money you get. Okay, does that make sense? So this is a really useful thing to do. So you'll get an occasional question where that, just remember it's price times quantity. So you were right, it's equal to profit plus cost, but for that to do you any good, you have to have information about costs and profit. So that's not the way to go. Okay, so that's R. What's marginal revenue then? How are we going to get marginal revenue from revenue? Take the derivative and haha, now we've got a product, so now we can find marginal revenue. And you see, now that we know the product rule, we know how to take the derivative of revenue, right? Because revenue is always going to be price times quantity. It's a product, so naturally the product rule is going to come into effect. So what are we going to do? Derivative of Q is just 1. Then 80Q times the derivative of this. Well, down comes the minus 0.003. E to the minus 0.003. And so now when we put it together, actually it'll look neater if we take out a common factor of the E to the negative 0.003Q. And then here we've got 80, then minus 0.003 times 80 is what? 0.24? Something like that. That's a nice way to tie things up. Putting it like this is a nice way to do it because we can see when marginal revenue is going to be 0. Right? We're going to see that there's a point when marginal revenue is 0 when the Q equals 80 divided by 0.24, we see that marginal revenue is going to be 0. That means that after that, the market becomes so saturated, we actually kind of lose money by producing stuff. Okay, so we know how to take derivatives of things, so that's going to be a standard question I'm going to ask you. You're going to get plenty of those. But as well, it's going to be the other type of questions as well. I'm going to ask you to interpret some economic thing to do with demand, supply, cost, and revenue, profit, that sort of stuff. Stuff with tangent lines, stuff with tangent line approximations. That's all good as well. You know, I'm going to be asking things like, you know, when is a function increasing? When is it a function concave up? All same kind of questions. Okay. Let's do the quotient rule then. Everyone finished with this? How to spell quotient? So what is the derivative of f of x over g of x? Well,
Do we even really need to know this one since we already know that?
some people like it, it depends. Some people like to have it, some people just whatever. So in fact, the way that we prove it is by using the product rule, right? Because f of x on g of x is the same thing as f of x times g of x minus 1. Okay? And so let's use the product rule. So it's f prime of x times g of x minus 1 plus f of x times the derivative of g of x to the minus 1. Now the way to do that is to use the chain rule. Right? So we go x to g of x to invert 1 over u. Okay, the derivative of this is g prime of x. The derivative of this is minus u to the minus 2. Right? So we get down comes the minus and we subtract 1. So putting them together, we get g prime of x okay. Let's do that in times g prime of x times on x squared. We do the same thing that we did over there. We put it over a common denominator. f prime of x times g of x, right? Because we've got to multiply this by g of x to get the x squared on the bottom, minus f of x. And that's the quotient rule. So some people can remember that and use it all the time, and other people don't want to remember it and just use the product rule. So the quotient rule is just a tad faster if you know it, but there's a little rhyme, little mnemonic to help you remember it. Because if you look at it, the main thing is you've got to remember, is it f prime g minus f g prime, or is it g prime f minus, you know? So the way you remember is you go low d high minus high d low. And I can always remember that. So that's how I remember the quotient rule. Just remember low d high. And that just starts you off. I find that knowing that, I think, can then remember the rest, just remembering low d high. Okay, so let's do this one again. And so instead of using it as a product rule, let's use it as a quotient rule. So we go low d high, x times the derivative of e to the x, minus high d low, times 1 over x squared. As promised, it's a little bit faster, but it's the same, you get the same answer. So it's up to you what you do. Oh my mask is killing me. Do you get like pain in your ear? I guess I need a bigger mask, I guess. How are we going for time? Oh, we're doing great.
How did you just get e to the x?
Sorry?
How did you end up with the minus e to the x?
Right, remember it's minus high d low. So it minus high is e dx times d low, x, the derivative of x is 1.
Oh.
It's just the way that let's just do some more examples, and then I'll ask you to do one. All this out of the way. X cubed squared over x cubed plus 1. Let's take the derivative of this. So what low d high, low is x cubed plus 1. D high is 2x. Minus high d low. And it's down the bottom square. So it's always a question of how much you should simplify. This one I'd simplify quite a bit because here I can see a 2x to the 4th, and there I can see a 3x to the 4th. So I'm going to see that things are going to simplify quite a bit. So I'd write that then as 2x minus x to the 4th. over x cubed plus 1 squared. That's a nice answer.
Is there ever a scenario where you'd want to like multiply out the binomial on the bottom and like
No, never,
cancel with that?
never multiply the binomial on the bottom. The rule of thumb is factoring is good, is the basic thing. So if you see something already factored, leave it alone. The question comes up here, should I simplify? Well, do you get nice factoring is the reason why. Because what's going to happen is later on we're going to see that when we take derivatives, a basic thing that we're going to do is set a derivative equal to 0. Right? And so if you have a fraction equal to 0, what does that tell you? It tells you the numerator is 0. The denominator doesn't play anything. So the denominator is really, doesn't give you much information. So typically you leave denominators alone. That's just a rough rule of thumb. Okay. Let's do another one. 1 over 1 plus e to the x. Again, what is it? Low d high, well, that's 0, right? Because the derivative of 1 is 0. Minus high d low, that's e to the x. 1 times the derivative of 1 plus e to the x is e to the x. Divided by the bottom squared. And that's easy to tidy up. This one I used the quotient rule. Again, we could have used the chain rule on this. We could have done it as 1 plus e to the x to the minus 1 and used the chain rule and we would have gotten the same thing. Ln of x divided by e to the x. So why don't you have a try at this? Okay, let's try this. Low d high. What's the derivative of log x? X minus ln of x times e to the x, right? Because the derivative of e to the x over e to the x squared. So what we could do is we've got an x here divided by x. So we could just multiply top and bottom by x. Just to sort that out. So that we get e to the x minus x ln of x e to the x divided by e to the x squared. And then do you notice that the e to the x's cancel out? Because we can pull out an e to the x here and we can pull out an e to the x here. So that equals 1 minus x ln of x e to the x divided by e to the x.
Do we have to do all that? Because, like.
No, it's okay. So in a homework, I would. In a test, I wouldn't. Right? Because homework, you've got time. You do it carefully. In a test, you want to make sure you get as much done as possible. So maybe, I would just put that and then maybe come back to it later. Does actually anyone see an easier way to do this? Right, because there's a product that's equal to e to the minus x times ln of x. So, and that would be more straightforward to do. So, you got to be aware that there's more than one way to skin a cat, right? There's more than one way to put functions together. So in this case here, the product is easier than the quotient. The quotient gets kind of ugly, but the product rule turns out pretty nice. Okay. Okay, so I've just bombarded you with formula questions, but of course, sometimes I give you other kinds of questions, like graphical or numerical questions. So let's say I give you this situation. So let's say this is 8. This is 8. Let's say this is g of x. And f of x, this is 4. This is f of x. Okay. And so I'm going to let h of x equal f of x times g of x. So what is the derivative at 2? So how would we go about this? We still have to do the formula, right? Because h prime of x, right, it's still going to be f prime of x times g of x plus f of x times g prime of x. And that's going to be true when we plug in 2 as well. So what we're going to do now is look at the formula to figure out what those things. So what's f prime of 2? So 2 is here. So what's the slope of f at 2? So it rises from 0, 0 to 4, 8. So what's that slope then? Yep. Yep, so it's 8 over 4. 8 over 4, right? It rises 8 over run of 4. So f prime of 2 is 2. What's g of 2? G of 2. G of 2. G prime of 2 is -1, right? Because its slope is -1. But what's g of 2? Well, if g prime of 2 is -1, it starts off at 8. What is it when it gets to 2? 6. And then what's f of 2? 4. Does everyone get that? We're dealing with straight lines here. The slope here is -1, the slope here is 2, the slope here is 0. Starts off at 8. So in a run of 2, it drops 2, so it goes to 6. Here, the slope is 2. In a run of 2, it rises 4. So that's why it's 4. So now it's just 12 minus 4 is 8. Okay, so this is quite a subtle kind of question, right? Because you have to do the formula, and then you've got to look at the graph to figure out what the values are to plug into the formula. But it's a program, right? It's a machine. Once you have the formula, you just figure out, well, what are the pieces? And go ahead and do that. You're all nervous, so that means you must want to leave. Okay, you can leave. Have a good one.